Students, we are doing questions from Concepts of Physics by HCVERMA Volume 1, Chapter 3, Rest and Motion, Kinematics, and we are doing the end exercise. Here is question number 7, students. The acceleration of a cart started at t equal to 0 varies with time as shown in figure. Find the distance traveled in 30 seconds and draw the position time graph. Students, here you have to pay one important attention that number one, car started. That means that its initial velocity is 0. Second point is that acceleration is given in feet per second square. So when you're finding the distance traveled, if you are sticking to the feet per second square in that way acceleration, then you will get the answer in feet. Please understand. And after that, we have to draw the position time graph. So to find the position time graph, or before that finding the distance traveled in 30 seconds, one of the easy ways to make the velocity time graph, and from that graph you get the distance traveled, because area under velocity time graph gives the distance or displacement, and from that you can make the position time graph. Students, so let us make this graph. First of all, the easy way to make is that you make a number line, make a graph which is exactly in time it is matching. For example, students, I will draw lines like this, vertical lines like this. This is the corresponding to 10 seconds. This is the line corresponding to 20 seconds. And this is the line corresponding to 30 seconds. So students, our times are available to us. This is the velocity time graph. This is velocity, which is in feet per second, students. And this is time t. Now, one thing I would like to mention here is that the area under the acceleration time graph gives the change in velocity. So, if I look at the area, how to get that area? Carefully see that this area under this acceleration time graph gives me the change in velocity. Initial velocity, I said that the beginning that it is 0. Therefore, this area gives the final velocity, because the change in velocity is final minus initial velocity, which is given by this area is 50. And in the similar manner, this area is, students, also 50. You carefully see this. Length into breadth. Here the length is 10 feet, 10 seconds, and the height is 5 feet per second square. Therefore, this area is also 50. So, students, the initial velocity, which is 0, increased to 50 feet per second. After that, from 10 to 20, there is no acceleration. Therefore, the velocity will not change and it will remain the same. Therefore, I can draw a straight line like this. After that, from 20 to 30 seconds, the velocity decreased like this. This completes the velocity time graph, students. We can say that it has got this has 3 regions: region number 1, region number 2, and region number 3. This is more like a trapezium, students. We can say that this is 50 feet per second, and this is 10 seconds, this is 20 seconds, and this is 30 seconds. Area under this graph, that is this particular area, gives me the distance covered. Actually, it is the displacement, but because it is in the positive side only, distance is equal to displacement. I hope you are able to capture what I am saying. This area, this is a trapezium, and if you recollect back, the area of a trapezium is given by half sum of parallel sides into height. Half sum of parallel sides into height will give the area of the trapezium, students. This area, you have to learn to recollect what you have learned in the lower classes. So this area of this trapezium, half sum of parallel sides, sum of parallel sides into height. What are our parallel sides, students? Please capture that. This is our parallel side and this is our parallel side. That is half sum of parallel sides. That is from here to 30, 30, and then from here to here 10, 10 to 20, that is 10, and into height is 50 feet per second, that is 50. So this comes out to be 1000 feet. So this completes one part of the answer, that is the distance covered in 0 to 30 seconds. He is asking another question, another part also, that what is the position? Please draw the position time graph. The position time graph we have to correspondingly make. We'll have another time, another xy axis graph like this. Students, this graph I'll make little, this has to be little bigger. So I will write down that this is my distance, position time graph, and I can write down that this is my time. I can extend the line which I already made for time. That is, I am extending this graph is there, this line, I am extending it till here. I hope you are able to capture what I am doing, students. This also I will extend. And this also I will extend, students. The purpose is that I can make the position time graph with ease. So I am ready with these lines, students. So you can see that I have ready with the times, that is, this is 10 seconds, this is 20 seconds, and this is 30 seconds. So first of all, the particle is going with an acceleration from 1 to 10 seconds. How do I show acceleration in the position time graph? By a curve, increasing speed. The speed increased to 50 meter per second. So I can have a curvature like this. In fact, I have tools to make such curvatures. After that, the velocity is uniform, steady, 50 meter per second, or the slope is 50 meter per second. That way, I'll make the graph straight line. Each of these corresponding points I have to do. What is the area of the region 1? The area of the region 1 is will give me this particular position. Which position? This particular position, that will tell me I find the area of the region 1. What is the area of region 1? Let us find out. Area 1 is is a triangle, students. Area of region 1, which I am telling is this region, that is a triangle, half base into altitude 50. That is 250 meters, 250 feet. Therefore, I will mark this as 250 feet. And after that, the area of the rectangle is of region 2, A2. A2 region will be half, not half. It is simply a rectangle. Therefore, simply 10 into 50. that is 500, and A3 will have a same area, that is 250. Therefore, the next corresponding line, that is, I am referring to this. This is marked as 500. feet. After that, there is a deceleration, students. So deceleration, students, I have to show by a curvature like this. As speed is going to become 0, flat. So using that curvature idea, I have speed has become flatter, students, 0. So, and the corresponding point I have to show in the graph, that is 1000 feet point. 1000 feet graph. 1000 feet. In this way, this graph is complete, students. I hope things are clear to you.